Hello everyone, I am Dr. Sudhan Sharma from School of Computers and Information Sciences, Indira Gandhi National Open University. And till now we are done with a differential calculus, wherein we learned what is differentiation. We learned about the concepts of functions, limits and continuities and how they are related to differentiability. Apart from this, in our previous session, we learned about what are increasing and decreasing functions. Apart from this, we identified the different tests, first derivative test and second derivative test to find the local minima and maxima. We also solved several real life problems wherein the concepts of differentiations are applied to solve those problems, and they may be considered as real life application of derivatives. And now we are going to continue our discussion to the next section of the calculus, that is the integral calculus. This session is about the introduction to the integration part. Integration is just opposite of differentiation, because many a times it is required to decompose the signal into the smaller segments, and many a times it is required to consolidate the signal, verify the continuum. So the consolidation part is taken care by the integration. So differentiation and integration are just opposite to one another, and many a times integration is referred as antiderivatives. So we are going to start the introduction to the integration part, and the objectives of the today's session are to define the antiderivative of a function and use the table of integration to obtain the antiderivatives of some of the simple functions. In our subsequent sessions, we are going to understand many more tricks and techniques to perform integration, that is how to perform integration by substitution, how to perform integration by parts. There are many cases and many problems which we are going to discuss. But to just begin with, let's understand what integration is all about. The very first expression is self-explanatory. In this expression, we are having a function. We are representing the integration by this sign, and integrating a function fx is to be is written in the format integral of fx into dx, where dx is the variable of integration and fx is nothing but the function to be integrated. That's why it is known as integrand. So integrating the function, you are getting the answer fx plus c. So that means this is the difference. Say in the graphical terms, say we are having a function, fx, and in some intervals we are having its value, and now all these values are to be composed. So in order to find the overall value of the function across the entire region, we are supposed to perform integration. And in a particular region, so that means integration is about the consolidation of the values, and it is written by in the format integral. This is the symbol for the integration of the function fx with the variable of integration dx, and it turns out to be fx plus c. Other way around, you can say that because it is the term antiderivative is used for the function for integration. So integral of f dash x dx can be written as fx plus c. Apart from this, you are having, because both integration and differentiation are opposite to one another, so you can say that ddx, that is derivative of the integral fx dx, and this will derivative and integral will be cancelled, so you will be having only single function fx. So I mean to say that differentiation and integration goes hand in hand, and both are opposite of each other. So we understood this concept of integration. Now we are extending our discussion by comparing the differentiation formulas with the integration formula, so that you can understand that how integration and differentiation are related to each other. So for the first formula in the differentiation says that the derivative of a constant is equal to 0. because the differentiation relates to the change, the rate of change. So the constant is not supposed to change, constant is constant. So at one point it is constant, at other point it also is constant, there is no variation in the constant. So the constant, the variation of the constant is equal to 0. That's why the derivative ddx of constant is equal to 0. But in case of integral of dx turns out only to be x. So if we say integral of k times of dx, then it should be written k into integral of dx, that is equal to kx plus c. So integral of dx is nothing but x. So far as the power formula is considered, in differentiation we are having ddx of x to the power n as nx to the power n plus 1. But so far as the integral is considered, integration of x to the power n into dx is equal to x to the power n plus 1 over n plus 1. This is the important formula plus c. So derivative of natural logarithm of x is 1 over x, and because the integral is opposite of derivative, so this is nothing but your f dash x, which is nothing but 1 by x, So derivative of f dash x is nothing but fx. And what was fx? Fx was ln x, so that's why it is ln x. Natural logarithm of x. So I hope you understood that integral of f dash x dx is nothing but fx, and ddx of fx is equal to f dash x. So that means this part is going here, then this part is coming as an output, and this is very much visible in this formula, wherein we saw that ddx of fx is equal to f dash x is written, say ddx of natural logarithm of x is turning out to be formula 1 by x. So 1 by x is your f dash x. So integral of f dash x dx will be written as integral of 1 by x dx, and that turns out to be fx. And what is fx? Fx is your ln x, so this is log of x. So I hope you understood that how integration and differentiation are interrelated. Now let's extend our discussion to the other formulas. We learned in differentiation that ddx of e to the power x is e to the power x. Because there is no change, that's why again it is integral of e to the power x into dx. Just remember the definition, integral of f dash x dx is equal to fx, and derivative of fx is equal to f dash x. Just keep these two things in the mind and you will better understand how these formulas are interrelated. Now, next important formula is ddx of a to the power x is a to the power x ln a, natural logarithm of a, and on the same lines, integral of a to the power x is a to the power x upon natural logarithm of a. And this is what we had discussed in the beginning, that derivative of a constant into fx is nothing but k times of derivative of fx. That is k times of f dash x. And when we are going to apply it for the integral, then integral of k times of fx will turn out to be k times of integral of fx plus c. So the formulas are very simple. This is a simple list of the formulas, and we are going to explore some more detailed formulas in our subsequent session. But just to begin with, you are supposed to refer to these formulas for both integration and differentiation, and this will help us to execute problems in our subsequent slides. So there is a general pattern to perform the integration, and what the general pattern, the flow is that we are given some integral, we are supposed to rewrite the integral and then perform integration by using the formulas which are given and which we had discussed in our previous slide, and then we need to simplify. So see, the integral given to us is 3 upon x to the power 4 plus 2 upon x square minus 4 upon x. Now, we can rearrange it in the format 3 into x to the power minus 4 dx. This is into dx. So this will be rewritten as 2 into x to the power minus 2 into dx minus 4 into 4 by x dx, you can say. You will be may ask the question that why this is not written into the format x to the power minus 1. So why it is not written? Because integral of x to the power n dx is equal to x to the power n plus 1 over n plus 1. So integral of 1 by x dx, if it is written as x to the power minus 1 dx, then the answer will be x to the power minus 1 plus 1 upon minus 1 plus 1, and this will be 0, though the function will not be, is not defined. That's why this expression is not written as x to the power minus 1. But over here, we are going to use the formula that integral of 1 over x dx is equal to natural logarithm of x. Rather, there is a formula integral of f dash x over fx dx is equal to natural logarithm of x, and which we are following it over here. Derivative of x is nothing but 1. So f dash x upon x is nothing but natural logarithm of x. So that's why by rearranging, we are getting the expression which is shown over here, and the expression is this. Now applying the formula x to the power n, integral of x to the power n dx is equal to x to the power n plus 1 upon n plus 1, you will get the answer for the first integral 3 into minus 4 plus 1 upon minus 4 plus 1. For the second integral, it will be 2 into x to the power minus 2 plus 1 upon minus 2 plus 1. And for the third integral, we are going to use the formula natural logarithm of x. So solving these values, minus 4 plus 1 will turn out to be minus 3. Minus 2 plus 1 will turn out to be minus 1. So solving these values, and to the power minus 4 plus 1 is there, so it turn out to be minus 3, and minus 2 plus 1 will turn out to be minus 1. So hence we are going to have the formula, this expression, this entire expression will resolve into 3 into x to the power minus 3 upon minus 3 minus 2 into x to the power minus 1 upon minus 1 minus 4 into natural logarithm of x plus c, and this solves to this expression. So the solution of the integral turns out to be minus 1 upon x cube minus 2 upon x minus 4 natural logarithm of x plus constant of integration c. I hope you understood how we perform the integration by simply using the formula which are listed in this table. So this is the first problem we had solved for the integration. Now let's understand how to solve the other problems. Again, a simple problem is given to you over here is 2x to the power 1 by 2 plus 3x to the power 1 by 3 minus 4x to the power 1 by 4 into dx is to be integrated. Now the first step was to rewrite. Now on the basis of rewriting, we just spreaded up the integral sign into the respective functions, and we rewrote the entire integral which is given over here in this format. Now again we applied the formula x to the power n dx is to be integrated, and we applied the formula x to the power n plus 1 over n plus 1 plus c, constant of integration. So integral of x to the power 1 by 2 dx will turn out to be 2 into x to the power 1 by 2 plus 1 upon 1 by 2 plus 1. That means it turns out to be 4 by 3 x to the power 3 by 2, because 1 by 2 plus 1 is nothing but 2 into 1 plus 2, that is equal to 3 by 2. So this is the answer for the first integral. On the same lines, we solve this integral, and the solution will turn out to be 9 by 4 into x to the power 4 by 3. And finally, this integral is solved and the answer turns out to be 16 by 5 into x to the power 5 by 4 plus c is the constant of integration. So I hope you understood how to perform the steps rewrite, integrate and simplify to integrate the expression. Now there is one more numerical wherein we are going to explore the formula of integral of a to the power x dx, which is nothing but a to the power x upon natural logarithm of a. So we are going to use this formula to solve this numerical. So firstly, we need to rearrange this expression. The expression given to us, the function given to us is 2x plus 3x by 5x, 5 to the power x into dx. So rearranging, you can get 2 to the power x upon 5 to the power x dx plus integral of 3 to the power x by 5 to the power x dx. So that means you can write this integral always as 2 by 5 to the power x dx plus integral of 3 by 5 to the power x dx. Now these are of the expression a to the power x dx. So simply apply the formula is equal to a to the power x upon natural logarithm of a. So integral of 2 by 5 to the power x dx will turn out to be 2 by 5 to the power x upon natural logarithm of 2 by 5. Similarly, the other expression, that is integral of 3 by 5 to the power x, can be done and they are to be added. And the overall solution turns out to be 2 by 5 to the power x plus upon natural logarithm of 2 by 5 plus 3 by 5 to the power x upon natural logarithm of 3 by 5 plus constant of integration c. I hope you understood how to apply the other formula. Till now we had explored three formulas. 1 by x dx is equal to natural logarithm of x. Second formula which we had explored is integral of x to the power n dx is equal to x to the power n plus 1 upon n plus 1 plus c. Third formula which we had explored is a to the power x dx is equal to a to the power x upon natural logarithm of a plus c. So these three formulas which we had explored till the moment. Now we are going to evaluate some more questions for your better understanding. And this question is again a to the power x plus b to the power x whole square upon ax plus bx. And we are supposed to integrate this expression. If you properly apply the steps, that is firstly to rewrite, then we integrate and simplify. So firstly we rewrite. So to rewrite, we follow the identity a plus b whole square is equal to a square plus b square plus 2ab. Applying this identity to a to the power x plus b to the power x whole square, you will get a to the power x square plus b to the power x square plus 2 into a to the power x into b to the power x. Divided by a to the power x, b to the power x is given to us. So we divided by a to the power x, b to the power x. Now rearranging a to the power x, a to the power x square upon ax bx plus b to the power x square upon ax bx plus 2a to the power x, b to the power x upon a to the power x, b to the power x. So simplifying, you will find that this will cancel out, this will cancel out and these two will cancel out, and you will get the expression a to the power x upon b to the power x plus b to the power x upon a to the power x plus 2, which can always be rewritten as a by b to the power x plus b by a to the power x plus 2, and which is this expression. Now we are supposed to integrate, so we will integrate it, and by just applying the formula integral of a to the power x dx is equal to natural logarithm of a plus c, this formula is to be applied to integrate this. We need to integrate a by b to the power x dx plus integral of b by a to the power x dx plus integral of 2 dx. So this will turn out to be a by b to the power x upon natural logarithm of a by b plus b by a to the power x upon natural logarithm of b by a plus 2 times of x plus constant of integration, which is this, and this is the solution, and this is how you are supposed to solve by applying the fundamental formulas, basic formulas for the integration. Now let's apply one more question to be solved over here, and over here we are going to apply one of the fundamental understanding, that a natural logarithm. So we are given a formula question that to evaluate integral of e to the power a natural logarithm of x plus e to the power x natural logarithm of a dx. We are supposed to integrate it. So you need to remember that natural logarithm of x is logarithm of x to the power a, and you can say that x natural logarithm of a is nothing but natural logarithm of a to the power x. You need to remember these two identities, these two expressions. We are going to apply these two expressions to integrate this. So let's integrate. So in order to integrate, firstly we rewrite the expression. So the first expression is e to the power a ln x. So it will be written as e to the power natural logarithm of x to the power a, and e and natural logarithm are opposite of one another. So overall answer turns out to be x to the power a. So this is the first expression. Similarly, e to the power x natural logarithm of a, it can be written as e to the power natural logarithm of a to the power x, and e and natural logarithm are opposite of one another, so it will turn out to be a to the power x. So a to the power x. So the expression given to us, this expression can be rewritten as x to the power a and a to the power x. So in place of this we are getting x to the power a, in place of this we are getting a to the power x. And you always know that x to the power n dx is nothing but x to the power n plus 1 upon n plus 1 upon n plus 1 plus constant of integral, and integral of a to the power x dx is nothing but a to the power x upon natural logarithm of a plus c. Applying these two identities into this expression, you will get the first answer is integral of x to the power a dx plus integral of a to the power x dx, and this will turn out to be x to the power a plus 1 upon a plus 1 plus a to the power x upon natural logarithm of a plus constant of integration, which is this value. And I hope you learned how to apply the fundamental concepts, fundamental formulas to perform the integration. And in the subsequent session, we are going to discuss about integration by substitution, integration by parts, and many more things in details. And thereafter, we are going to discuss how the application of integration in real life, that is how to find the area of curves. So I again request you and recommend you that practice more and more problems, revise the concepts so that you are able to understand the subsequent sessions. Thank you very much.